So we've got two triangles, ABC and DEF. Angles B and E each have a measure of 27 degrees. Angles C and F each have a measure of 41 degrees. Which additional piece of information is sufficient to determine whether the triangles are congruent to one another? Measure of angle A. We know the measure of angle A. I guess not directly, but we know that all the three angles in the triangle add up to 180. If I take 27 and 41 off of 180, that gives me the measure of angle A. We already know that these two triangles are at least similar to each other by angle, right? If they have two angles that are the same measure, the third angle automatically is the same measure. But we could have one of those triangles really tiny, one of those triangles really large, that all have the same angle measures. So we don't need to know the measure of angle A to determine if they are congruent. That doesn't provide us with any more insight as to whether or not that is the case. The length of side AB. Well, if you only know the length of side AB, that tells you more about the initial triangle, but it doesn't tell you anything about the second triangle. Check out option C, the length of sides BC and EF. So if the side measure between the two angles that you know are the same on the two triangles, that will allow you to decide whether or not the triangles are congruent by angle, side, angle, right? If we have an angle, a side between, and then the next angle, and they're the same for the two triangles, that does tell us that the triangles are congruent. So if BC and EF have the same measure, they're congruent. If BC and EF have different measures, that would tell us that they are just similar to one another.